Hey, everybody. Really excited for this chat today as we dive into AMD's AI vision and strategy with a true insider. Ramin, how are you?
I'm good. Thank you. Thanks, Evan.
Well, thanks for being here. I've been really looking forward to this chat. Before we get into the details, perhaps introduce yourself, your role, your team's role within AMD, and the big picture. What is AMD doing in AI right now?
Sure. My name is Ramin Roane, and I'm leading the group in the AI group at AMD that's basically leading the integration of the open source ecosystem with our GPU. And we're also responsible for DevRel, developer relation. And what AMD is doing in AI right now, well, we have products that can accelerate AI from the endpoint all the way to data centers. So at the endpoint, we have AI running in self-driving cars, in satellites, even on Mars, on the Mars rover.
Wow.
In hospitals doing analytics and genome analytics and things like that. And then we have AI PCs on laptops and desktop at the edge, and then the big Instinct GPU in data centers.
Wow, it's an amazing portfolio, amazing breadth of technologies. And central to that vision is open source, which is very impressive. Maybe talk about that and how does AMD approach that rather differently from others, perhaps?
Yeah, so for one thing, our entire stack is open source. So the Rocm software, which is our software stack to program our GPU, which was first specialized for HPC, since AMD is really big in HPC. We have like the top 2 or 3 biggest supercomputers in the world. And then we have, maybe 3 years ago, we have adapted that to AI, which uses, smaller data types, like more FP8, FP4 than FP64, like HPC. So we've done our first AI GPU in 2023 and adapted Rocm to do the whole AI stack. And everything is open sourced. And we also very quickly realized that companies are actually using open source software. Like if you look at OpenAI, they're using their own branch of VLLM, which is a open source software for inference serving, and XAI uses their own branch of SGLang, which is another open source software. So we very quickly started to work with the open source community, with the PyTorch and VLLMs and SGLang and Unsloth and Hugging Face and so on. We provide them with machines to do daily CI/CD and work on supporting all the features and all that. And it's just super important, not just for enterprise, but even big AI labs. Everybody is using open source.
Absolutely. And you talk a lot about not just the software innovation, but combining that with hardware leadership. Tremendous synergy. How does that show up in real world performance?
Oh, so we basically, as I said, we came up with our very first GPU in 2023. It was at the very end of 2023, like December. And we started to sell it in 2024. And we basically went from 0% market share to 5% market share in our first year in AI against the biggest, baddest GPUs out there, right? So we're extremely competitive. Our customers are not smalls. They're, the OpenAIs and Metas of the world. So we're basically competing with the number one, the biggest GPUs out there.
Yeah, it's amazing. And you have so many developers, so many examples of where hardware, software synergy has already delivered results. Can you share any of those stories or anecdotes, examples where you're getting really measurable performance or efficiency gains?
Yeah, sure. So for one thing, our GPUs are not just competitive in compute; they actually go way above and beyond in memory and memory bandwidth, and that's because we have accumulated a wealth of IP and technology on the EPIC side. Namely, we're chipletizing our devices. it's not just 2.5D, it's actually 2.5D on top of 2.5D. Like we have the memory hierarchy and the IOs on the first floor, and we have the compute on the second floor. And that allows us to pack a lot more compute in the same device and put a lot more HBM. Just to give you an idea, when our first AI GPU came out, MI300X, we had 192 gigabytes of HBM. The biggest, best, number one GPU out there had only 80 gigabytes. So we were like almost 2.5x more in terms of memory, and more than 1.6x the bandwidth. And obviously, LLMs are extremely hungry, not just in memory, but also in memory bandwidth, at least for the decode side of LLM is very memory bandwidth intensive. And that's why we got very quickly adopted by the Microsoft and OpenAI and Metas of the world. So
it's phenomenal.
Yeah, and it's a combination of hardware and software, right? Because then on the software side, things are moving very quickly, but honestly, the state of the art in software is no longer proprietary. There is no proprietary mode. It's really open source. It's what VLLM and SGLang are doing. No proprietary stack can match. They're moving way too fast. So on the software side, we're taking advantage of our memory bandwidth at the same time as keeping up with the state of the art, because we were directly working and developing with open source.
Fantastic. And clearly Frontier Labs and others are betting big on AMD for AI. Okay. And a lot of that is through partnerships, really helping shape your future as well. Any lessons or insight into those partnerships and the partner philosophy that you're driving?
You mean with our customers, right?
Yeah, customers and partners.
Yeah. So that's really key, actually, to any product development. You want to work very closely with the users of your technology, whether they're customers or partners, and understand the gaps that they're seeing out there, and fill those gaps. So we understand the gaps, work with them, work with the internal engineering team, propose solution, and the solutions that customers really echo well with, we implement them. It's really product management 101. You want to understand the gaps and fill the gaps.
Yeah, back to the basics. Love it. You mentioned AMD technology is on Mars. I love that analogy. I'm a space tech geek as well. So if AI is the rocket, what makes AMD the launch pad? What's the mission control behind the launch? You have people, partnerships, platforms. Is that a good analogy, or is that did I go off the rails?
That's a good analogy. I would say the launch pad is the community. It's really the community. The open source community is nothing would take off without them at this point of time. Again, there was a time where proprietary software was the only thing available, and therefore the state of the art. That time is long gone, and really without open source, none of that could happen. Yeah, we have great technology. Yes, we have advantages on chiplets and 3D packaging and all that, but none of that would take off without the open source community.
Yeah, it's fantastic to watch. Let's talk Rocm 7, your developer platform. It kind of evolved from being an AI software stack to much more. Maybe talk about that evolution and where it is and where it's going.
Sure. So Rocm 7 is a big change in that we completely re-architected Rocm. So it's more modularized. It's much smaller to install. That was actually one of the big pain points from our partners, is that it was too big. Rocm was just too big. So we trimmed it down, modularized it. It's completely open. Right now it's on a GitHub called the Rocm. So it's AMD the Rocm. And you can install just the pieces you want. And at the same time, we've been keeping up with the needs out there. So we have a full enterprise AI stack, because, when we cater to the Metas and the OpenAI of the world, they have their own stack, right? They don't need us to manage their own cluster. But when an enterprise company is buying our GPU, what do? They need a way to bring up that stack and start distributing workloads and using the GPUs efficiently every hour of the day, right? So we have a full-fledged enterprise stack, which is also open source, that's out there. We actually announced it in wide availability just today. So we have a blog on our website with all the links that are needed to access to that. And another big thing we're doing in Rocm 7 also is to catch up to a new trend, which is distributed inference and disaggregated inference, because now that Frontier Lab are inferring at least as much as they're training, if not more, inference efficiency has become a big thing. And one thing that the open source community really figured out is that by disaggregating prefill and decode, so prefill is the part of the LLM that analyzes your prompt, which could be, for example, a whole book, right, to summarize. And decode is the part where it's just generating, right? By disaggregating those two phases and running them on different pools of GPUs, you actually get much higher efficiency because they're just specialized workloads that you don't want to run on the same GPU because they're going to start interfering and slowing each other down. And then so that's disaggregated inference, and we also enable distributed inference in Rocm 7, which are things like for mixture of experts, for example. You can run different experts in different GPUs. You bundle experts and run them on different GPUs, and then you have to take care of all the GPU to GPU communication. The GPUs actually communicate directly, bypassing the whole networking stack running on CPU. So all of that is coming with Rocm 7.
That's fantastic. Are there any particular industries or workloads that you think will take advantage most and kind of stand out here?
AI is changing the game of business. Will you be on the winning team? I'm Jordan Wilson, the host of the Everyday AI podcast, and your coach to help you learn the X's and O's of AI. Artificial intelligence isn't just a new player in the game, it's a new sport altogether. So if you don't quickly put AI into play, your competitors will run up the score. I've spent my whole life building winning teams, from coaching basketball to working with big players like Nike and Jordan Brand. My next move? Helping you win with Everyday AI. Listen wherever you get your podcasts or on everydayaipodcast.com. Let's tap into AI together and put points on the board.
Yeah, so definitely LLMs. That's one of the top use cases. Although we're also running things like diffusion, search, ads. We have customers now really across the spectrum: video generation, image generation. But a lot of those are either attention-based or diffusion-based, or just classic ML for search and recommendation. Those are the workloads we're mostly focusing on. And enterprise AI is really the big new use case that we're also enabling in Rocm 7.
Yeah, very, very exciting. And when it comes to enterprise, how do you think about integration with existing AI frameworks and tool sets and stacks? There's a lot in the enterprise out there that's legacy.
Oh, everything we have in the enterprise stack is based on open source. So we are using the Kubernetes and Slurms and VMs and OSs that are available out there. Again, it's based on talking to customers and getting information from them on which stack they want to use and what their problem is. And so that's exactly what we did. We got the legacy and the state of the art in the open source community and enabled it.
Fantastic. So it's a competitive landscape, obviously, in AI. And, reducing deployment costs is crucial. Total cost of ownership is being looked at. How do you think about Rocm 7 helping organizations, enterprises achieve, these goals?
So yeah, as I said, cost is very, very important to our customers. So for inference, just like for training, you just need to try to get to maximum utilization of your GPUs. That includes using as many GPUs as possible, but also using as much compute as possible in the GPU and generating tokens really, really fast for the compute and for the power consumption that you have, right? So things like distributed inference are basically meant to optimize ROI. So it lowers the cost per token, basically.
Fantastic. Any real-world examples or benchmarks delivering cost efficiency? I know I'm not going to ask you for a price list here, but this must be increasingly an ask of your customers and partners.
Yeah, I mean, without giving dollar per token per watt kind of metrics, just to give you an idea, if you infer LLM the old way, which means how we were doing it 12 months ago, that's a very long while ago, compared to using disaggregated and distributed inference on a cluster of GPUs, you can probably slash down the cost of tokens somewhere between 10, 20, 30x, depending on the LLMs and on how many GPUs you have. But yeah, basically inferring everything just brute force on the same set of GPUs, prefill and disaggregation mixed up versus doing it cleanly, properly disaggregated and using expert parallelism. Yeah, that's the kind of improvement you can get. 10 to 30%, 10 to 30x, I would say, is doable.
10 to 30x. Wow, that's blockbuster. Amazing. So moving a little bit away from the present, there's a lot exciting happening, but maybe talk about the future of AI compute. How do you see this evolving over the next couple of years or beyond? Any insights you can share there?
So, yeah, you see a lot of headlines on the big mega deployments, right, in the data center. I think this will go on for a while because, at least big training is going to continue to be a thing because models are improving and you have to build and train new models. But I think on the inference side, honestly, as edge devices become more and more powerful, I think you're going to see a lot more inference moving to the edge, from the data center to the edge, to desktops, laptops, phones. I mean, if you just look at your cell phone today, and you look at the amount of compute and the little wattage it's using, like typically it can do 35 teraops at 4 watts, and you compare that to one of the first supercomputer, like in the 1970s, the Cray one, that was 160 megaflop, I believe, at hundreds of thousands of, more than 100,000 watts. If you do the calculation, you see that the TOPS per watt has improved by like more than 6 billion X. And the funny thing is, if you bring that to an annual rate, it's exactly 2x every year and a half. It kind of resembles Moore's law, but it's in performance per watt.
Amazing.
And the improvement hasn't come just from hardware like Moore's law was at the time, but from really hardware, software, and architecture, and even data types, right? Moving from FP64 to 32 to 16 to 8 to 4. Yeah, we're improving basically 2x per year performance per watt, and that means in a few years, cell phones will have the same power as a data center GPU today. So yeah, that's how I see it. I see that inference will move more and more to the edge, to the endpoints. And eventually, in a longer time frame, even training could, with federated training, right? This is more like 10 years maybe from now. But I don't think we're going to continue this unsustainable gigawatt consumption for AI. This is all going to go down, just like the Cray was using 100,000 watts, and now it's using 4 watts in your pocket for 6 billion times more power. This is what's going to happen for AI as well.
Well, it's going to be fantastic to watch it unfold. And it's not just the tech and AI giants that you're working with. You're supporting smaller teams, startups entering the AI race for the first time. I see your posts about this every day. Amazing innovation happening. That must be very fun and gratifying.
Yeah, absolutely. Yeah, I was at a hackathon just yesterday, Sunday, in San Francisco at a startup called Liquid AI. And yeah, that's what they do. They do small models, small LLMs that can run on incredibly small devices with not a whole lot of compute.
Well, fantastic to watch. So if we were to jump ahead to 2028, like in the Back to the Future movie, and what sort of milestone or breakthrough would you see signaling that AI's AI vision has really come to life? What would you hope to envision there in the future in 2028?
Wow, 2028 is in a long time.
In AI terms, that's like decades, yes.
Right. I would love to see AI moving into more industries. I mean, today, the industries that AI is really transforming are things like coding. Coding is definitely one of the top use cases. Obviously, chatbots like ChatGPT, that goes without saying, that is more on the consumer side. But also, there's a lot of innovation happening in biology and medicine with AI, with genome analytics and protein folding and medical imaging. So I would love to see AI have more breakthrough there. Okay, I guess the one single thing I want to see by 2028 is AI proving a theorem that humans have never proved.
Wow.
That would be a major breakthrough. Like
one of the millennium problems or something like that or finding unifying the theories that Einstein never could, right? Coming up with quantum gravity or something. That would be fantastic. Well, that would be. And I don't think we even need AGI to get those kind of breakthroughs. Speaking of the future and other topics that might be relevant, do you think we'll see quantum computing at real scale and real utility, real use in our lifetime? I know you're involved in different initiatives.
Lifetime. I'm skeptical, honestly. Okay. I think we're going to see a lot of improvement in quantum computing, but one of the biggest problems in quantum is that those qubits are actually not stable at all because they're in a quantum state. If they interact with any other particle, they collapse. So that's why it has to be in vacuum. It has to be close to 0 Kelvin. You shouldn't have electromagnetic wave passing by because that's like a photon hitting your particle. It's very, very finicky, very, very sensitive. So when a company announces that they have 1 quantum bit, 10 quantum bit, 100 quantum bit, it's not actually true. A quantum bit is really a logical quantum bit is actually physically implemented on 1,000 quantum particles. They basically spread the state of 1 quantum particle on 1,000, and they constantly have to monitor for error and error correct. And this is the biggest problem in quantum computing, and nobody has cracked the nut. I know Microsoft had a couple publications saying they came up with a topological qubit that is not sensitive to errors and all that. This has never actually been peer reviewed, and turned out it wasn't totally the case. I think we're still pretty far from having stable quantum bits, and even when that happens, the quantum algorithms are not actually fit for all the algorithms we use today, right? They're very specific to like combinatorial optimization algorithms or cryptography, but they can just be used for regular algorithms that we use in every day. So it's going to be a combination of quantum and CPUs and GPUs.
Really.
But in our lifetime, I don't know if there's going to be such a big breakthrough.
Well, it'll be fascinating to watch for sure. Speaking of technologies, I'm excited about. I just recently got an AI PC, actually powered by AMD. And I do a lot of cool local stuff involving editing and video and AI locally. So I'm excited, but I'm a tech geek. I'm an early adopter. Do you think AI PCs are going to really take off? Maybe we'll see more at CES this January, or, is this still mostly a data center cloud story?
Yeah, they will take off. As I said, just the rate of improvement will make AI PCs in a few years, like in a year or two. I think AI PCs are going to be as powerful as the data center GPUs of maybe 3-4 years ago. And that trend will accelerate. Yeah, I totally believe it will take off.
Well, good to know that investment was well made. And a final question here: do you think we're in an AI bubble? All the media and journalists are super hyped on this topic, or are we looking at growth that is really backed by fundamental change?
Yeah, I don't think we're in a bubble. I do understand Michael Burry's concern. He's concerned that there's too big of a gap between free cash flow and earning, and the difference between free cash flow and earning is basically how your amortization schedule of all the GPUs that you're buying for your data center, right? When you're a hyperscaler, they used to amortize that in between 2 to 3 years, and now they're amortizing that in between like 4 and 6 years. So they're saying they're using their GPU for a longer time, even though nowadays there is a GPU coming out every year. So are you really using it for 6 years? I somewhat think they actually are. There's still a lot of old GPUs out there in the cloud, and they're actually used. But in general, I mean, taking a step up, there is a big shift happening in compute, and that's basically turning regular algorithms, like optimization type of algorithms, and even algorithms that we could never write before in regular CPU programming. We're turning those algorithms into deep learning. And the reason we're turning them into deep learning is because deep learning is almost 100% parallelizable. The algorithms we had before had, let's say, 20-ish% a sequential core to it. And that's why with multi-threading, we could never improve by more than 5x, right? If it's 20% sequential, 80% parallel, the best you can do by using maximum multi-threading is to get rid of the 80%, but you still have the 20% left, so you accelerate it by 5x. With deep learning algorithms, you don't have that. It's almost all parallel, and you can accelerate an algorithm by 100x, 1,000x, 1,000,000x, 1,000,000,000x. You can keep on going, and that's why we're not just accelerating algorithm like in HPC and all that by turning bits and pieces into deep learning, but we're creating new algorithms that we could never have done before, like image recognition, video generation, LLMs. So all that requires a shift in compute, and I don't think we're in a bubble. I think we're just shifting to a new type of compute. It will eventually calm down. We're still in our exponential phase. It's eventually going to settle down in a few years. Now, yeah, there is a lot of excitement. Maybe there's some overexcitement in bits and pieces of the market, but in general, I don't think we're in a bubble that's going to burst in a year or two. I don't believe that.
Well, I could listen to you for hours, but sadly, I have to let you go. Thanks so much for the insights, the insider's perspective, and a brief view of the future at AMD. I really appreciate it.
Thank you. Thank you, Evan. Thanks, everyone.
Thank you. And thanks, everyone, for listening, watching, and sharing this episode. Talk to you soon. Bye-bye.